Hello and welcome. The following presentation is a PTC webcast on the importance of systems engineering for smart connected products, featuring industry research firm Ovum, now a part of Informa Group, the world's leading provider of business intelligence. In this webcast, you will begin to understand how the demand for smart connected products has magnified the complexity of product development today, and how it will change the way you create, operate, and service your products. In this segment on the importance of systems engineering for smart connected products, Michael and Hedley provide insights into best practices for improving system design.
Sure. So what we're looking at here in this diagram is X in the loop, where X is any of those approaches bulleted on the left, and virtual prototyping. So as I mentioned in a previous discussion, we want to shift left. We want to take testing upstream in the life cycle process, and this is what model-based engineering allows us to do. And where we have a plant or environment, and then the product within that, and then processes within that, and then the embedded software at those various systems level that we talked about earlier as well, we're finding, for example, that in the past we did the testing out in the field or on the road. We then moved the testing into the lab, and now we find that there is a tremendous advantage in moving the testing into the computer, doing the modeling and simulation. And this is what X in the loop and virtual prototyping allows us to do. So we can swap in and out any element depending on whether it's available, whether it's built, whether we want to interface against it, or whether we want to simulate it completely. We have all of those possibilities available to us, complete flexibility. And with that, there's also the advantage of auto-generating code that will end up in an electronic control unit, for example. And by auto-generating the code from the models, we can take out a whole category of software defects, the sort of bugs that are made from typos, that type of case. We will never eliminate design defects, but that's the advantage of doing the testing at an early phase, in that we can iron out issues in the design, with the design using models and simulation. So all in all, these are best practices for model-based engineering.
Yeah, thanks, Michael. There's some very good best practices and techniques there. We would also add to that and say that there's also some very good standards out there for best practices and processes for systems engineering. And in fact, we would recommend ISO 15288 for systems engineering. It's a great set of best practices there. And the very recent standard ISO 26550, which is the product line management and engineering for software and systems. Word of caution, you need to apply your own intelligence to those best practices, and most organizations tune them to their own domain expertise and knowledge. And then within those kind of higher level life cycles and processes, there's probably three main areas of focus and maturity. Firstly, model-based systems engineering, using standards such as the OMG modeling language called SysML, which is a graphical design language. And that doesn't provide process as the standards above do, but it provides a very good language for communicating and documenting and designing and analyzing systems. Then we can layer onto that with an approach for asset-based modular design. Again, there's another good best practice of the reusable asset specification, which helps you when you're trying to design systems of systems and their interfaces and how they all plug together. And then finally, on the best practices here, we would then recommend maturing on to product line engineering and using standards like the orthogonal variability modeling standard for design of product lines and their variation. Of course, then with those best practices, we'd also recommend that you automate those with tooling, and ideal tooling would include functions to enable requirements engineering, system design and analysis, and the outputs of testing and documentation, so that you can get that design consensus and find problems much earlier in the life cycle.